question, after how many time constants does the current reach within 10% of its maximum value? Okay, so you have 10%, 1%, and 0.1%. And the problem is about a circuit that has an inductance and a resistance. And I is given by I naught or Im, 1 minus e raised to minus t by tau, where tau is the time constant. So when you rearrange that, you get it in this format, and t is equal to minus tau natural log 1 minus I by Im. Now that's because in place of exponential, you always write natural log on the other side. And now since we have this equation in this format, we can substitute. The first part says 10%, so I by Im is 0.9, because it says how many time constant does the current reach within 10% of its maximum value. So that means the current I has grown to 90%, right? Okay. So the same thing. So the first answer is 2.3 times the time constant. Second one has grown to 99%, so takes more time, 4.6 tau. And the third one is 99.9, so 6.9 tau. In the second question, calculate the reactance of an RMS current in a 160 millihenry radio coil connected to a 240 volt 10 kilohertz AC line. You've got to calculate the reactance of an inductance. An inductive reactance is given by 2 pi times the frequency times the inductance. Frequency is 10 kilohertz, that is 10 times 10 to the power 3, and inductance is 160 millihenry, that's why it's 10 to the negative 3, and you get this as the answer, approximately 10 kilo ohm. And now to calculate the current, just use the Ohm's law, which is voltage is the product of current and reactance. Rearrange that, the voltage is 240 volt, and you get 2.39 times 10 to the negative 2 ampere. In this one, what is the reactance of a capacitor? And the voltage is again given and the frequency is there. Now capacitive reactance is 1 by 2 pi Fc. Therefore, frequency being given as 720, capacitance is in microfarads, so it's 3 times 10 to the negative 8 because it's 0.03 times 10 to the negative 6. Gives 7368 ohms. And then you have to find the peak current, and peak current is square root of 2 times the RMS current. And the RMS can be found out by Vrms by Xc as shown here. Putting everything together, you get it as 0.38 ampere. And in this question, what you have to find the total impedance, phase angle, and RMS current in an LRC circuit. The values of the inductance, resistance, and capacitance are given. Wow. The impedance is given by square root R squared plus XL minus XC whole squared. And it's always better to calculate XL and XC individually and then substitute it back into this. But in this case, I'm just trying to do all of it together. And the resistance is 8.7 kilo ohms. That's why it's 10 to the 3. And 2 pi times the frequency is 10 kilohertz, which is 10 to the 4 times the inductance is in millihenries, and that's why it's 0.0220 minus 1 by 2 pi f, again frequency, and C, capacitance, is in picofarad, so you have 10 to the negative 9 there. When you do all that and calculate, you get 8,777 ohms. Okay, and the phase angle is given by tan inverse XL minus XC divided by the radius. And now this is an important problem because it deals with an LRC circuit, and you actually have to calculate everything. So once again, when you substitute for XL and XC, you get, that's the frequency, 10 to the 4, inductance, minus 2 pi, again the frequency times the capacitance. You got to be very careful when you do all these calculations, because there are many chances of you going wrong. So you got to be very careful. In this case, you get it as tan inverse of minus 1164 by 8700, which gives minus 7.62 degrees. And the RMS current is V RMS by Z, and the voltage RMS value is 725, so divide that by the impedance and you would get the RMS current. 8.26 times 10 to the negative 2 ampere. And the last one in this question, again it's an LRC circuit. The inductance is given, the resistance is given, and the question is, what value must C have to produce resonance at 3600 Hertz? Now, the resonant frequency in an LRC circuit is given by 1 by 2 pi square root of LC. Since we are asked to find the value of capacitance, rearrange it and plug in the values of inductance and resonant frequency. You can see that I've squared both sides to get rid of the square root from here, and that's why this has a square there. Okay. And you get 1.32 times 10 to the negative 7 farad. And the next question is, what will be the maximum current at resonance? Remember that at resonance, the impedance is just resistive in nature, because the inductive reactance and the capacitive reactance become equal in magnitude and opposite in direction. They cancel out. So at resonance, the impedance is minimum and it has a value equal to that of the resistance. That is why the current becomes maximum. And it's given by 150 divided by the resistance. You get 34.1 ampere. And hopefully you would try to look at all these problems and prepare for the exam. Thank you.